Remember from our previous section, we talked about some of these function guarantees, right? So same arguments, same return value, no side effects. In other words, all Elm functions are pure. This is not quite true in JavaScript. It's not quite the case that all JavaScript functions are pure. In fact, there's really no guarantees around whether or not functions are pure in JavaScript, and which is why in a lot of JavaScript libraries you have things that say, like in React, like, hey, your render functions should be pure. Please make sure you don't do side effects in your render functions or your Redux reducers. Please make sure that they're pure. It's really important that they're pure because otherwise bad things can happen. In Elm, you don't have to worry about that because all Elm functions are guaranteed to be pure. However, this is a section about talking to JavaScript, which means that we have to deal with the fact that while Elm functions are pure, and we want to be able to rely on that and put it out of our minds and not have to think about these things, not have to have these worries, we also want to interoperate with a language where those guarantees are not in effect. So how can we do that? Right? How can we deal with a world where we have stuff like math.random or setting stuff in local storage directly? In other words, how can we access the enormous JavaScript ecosystem, the largest in the world, with all these millions of, it's not millions, but it's a large number of packages, while maintaining all the guarantees that let us code in Elm without worrying about all those things? So the answer is that the way that Elm talks to JavaScript is essentially using the metaphor of client-server communication. It's message passing. It's sending immutable data from Elm to JavaScript, and then receiving immutable data from JavaScript to Elm. Unfortunately, as we just saw in the previous section, we can do that in Elm without losing any of our guarantees. We just did in the last exercise HTTP, which is sending data from Elm to a server written in a completely different language. We have no idea what language it is. It could be JavaScript, could be PHP, could be Python, Perl, Ruby, assembly, anything. We have no idea what the guarantees are, but we don't care because all we're doing is sending immutable data to it via like an HTTP post or a GET, and then we're receiving immutable data back from it, which we then decoded into our Elm application. And at no point did we ever have to worry about sacrificing any of these guarantees, any function purity, anything like that. Now, we're not literally doing client-server communication to talk to JavaScript because that would require going over the network to go out to the network and then come back to the browser, which would be way too much overhead. But metaphorically, that's what we're doing. The API is designed to have the same characteristics as client-server communication so that we can freely communicate to JavaScript without sacrificing any of these guarantees that we've had throughout the course of the entire workshop. So basically, Elm sends data to JS, and then JS can send data to Elm, and that's how they communicate. There's no direct function calls at any point in this. So you cannot, in the middle of an Elm function, say, hey, call math.random. Can't do it. Instead, we're going to use commands and subscriptions exclusively to communicate with JavaScript. So there's sort of like two ways that this goes. So when you send a command from the Elm side, that's going to result in a callback being fired on the JavaScript side. So here's our command that we're sending. It's not quite going to be a command with a capital M like what we've had before. It's going to actually result in a command with a lowercase m. So we're going to go on a brief tangent and explain what that means when you have a command with a type variable that is unbound, which is to say a command where the type variable has a lowercase m, but there's no like message anywhere else in this function. Up to this point, every time we've seen a type variable, there have been two of them. Right? We had like list.reverse had like list elem to list elem. This is just command message lowercase m, but there's no other message anywhere. It's like not corresponding to anything. What does that actually mean? Okay. So at this point, all of our type variables have come in pairs, but list.length is one that we sort of intuitively know how it works, but it doesn't come in a pair. Right? List.length says, oh, you know, you can give me a list of anything, and I can tell you what the result is. It's an int. No matter what type of list you can give me a list of strings, a list of integers, list of floats, anything, and I'll tell you what the length is. So kind of intuitively, we can figure out, well, all right, that makes sense. I guess it's saying it's a type variable because what it means is this is flexible. We can give it any list we want, and it'll be able to give us back an int.